whenever we deal with nth roots and rational expressions, basically all we're doing is taking any of the rational exponents, okay, and we can turn it into a radical, or vice versa. Okay? So whenever we have a lot of this, whenever we talk about real nth roots of A, okay, all we're talking about is how many different answers can we have. So if it's an even integer versus it being an odd integer. Okay? Whenever you have any sort of even integer, okay, we dealt with, whenever we were dealing with quadratics especially, if you had a negative underneath the radical, what kind of answer did you have, or did you come up with? It was imaginary, right? Okay, so that means that if it's imaginary, then it wasn't real. Whereas if whenever we took the square root, or whenever we dealt with like the discriminant or the square root of a value, and everything canceled underneath whenever we did the quadratic formula, or we just found the discriminant and it was zeroed out, then we just had that one real solution. And then whenever it was positive underneath the radical, it was, you had two answers. Okay, or you had two real nth roots. Okay, none of this really changes for kind of the part here on the left. Okay, this section here really doesn't change from what we've talked about before. Now, one thing that you may notice that right here, that if you have it as a rational exponent, okay, if you have a fraction in the exponent position, that's the same thing as a square root. Okay, and we'll get to that in a second. Whereas with an odd integer here, there is never, it doesn't matter so much as far as it being positive or negative. Okay? For all of these, you have one answer. Okay? If it's positive, if it's negative, if it's zero, it's still going to be one answer. Okay? It will always be one answer. Okay? If your root, so if this little bitty number right here is an odd number, if it's 1, if it's 3, if it's 5, whatever, okay, you will always have one answer, and one answer only. It's when it's even that things can change. Okay? What's over here in the blue box, you've already dealt with already before, first semester, previously. Okay? That you can have different types of answers. You can either have no answers, you can have one answer, you can have two answers. Whereas if it's an odd value, then you're always going to have one answer. So it's either going to be one of three things. It's going to be negative, it's going to be 0, or it's going to be a positive value of whatever number it is. There's no such thing with an odd integer or an odd root of plus or minus, okay, like there is with an even. Okay, so whenever we do this, a few things that I would kind of make sure, we already know the perfect squares. Okay, we already know 1, 4, 9, 16, so on and so forth. Okay, it's the numbers, it's the perfect cubes, it's the perfect fourths, perfect fifths that you need to make sure, as far as like a cube, knowing the first so many. Okay, so like if I have a cube, I have 1, I have 8, I have 27. 4 to the third is 64, 125, 216, 343, 512, 729, and then 1000. So as far as perfect cubes, those are values that I'm going to need to know, okay, or going to need to remember. Now again, if it's perfect and it's a cube, that means the same values apply if it's a -1, a -8, a -27, a -64. Okay, whenever I'm talking about my roots and things of that nature. So like if I want to know what number times itself 3 times gives me a negative 216. So of my perfect cubes, okay, so whenever I deal with a cube, that's whenever n is equal to 3. So anytime it says that n is equal to 3, I'm going to deal with a cube. So do I have 216 in my list? Yeah. Okay. Which number in my list is 216? Is it the first one? Is it the 7th one? Is it the 10th one? Is it the 13th one? It's the 6th one, right? Okay. So that means that I'm going to have some number to the third power is going to equal negative 216. So we already said that this is the 6th term, right? But am I going to multiply 6 times itself 3 times? What do you notice about this value right here? It's negative, right? So what number times itself 3 times is going to give me a negative 216? Positive or negative? What kind of answer do I have right here? Negative. Is this odd? Yeah, so how many answers or how many roots am I going to have over here? 1 answer, right? So whatever, if it's odd, and this is negative, so that means that negative 6, okay, so my root here is negative 6. Negative 6 to the third power, if I take negative 6 times negative 6 times negative 6 and I multiply it 3 times, it's going to give me the negative 216 that I had right here. If it's an odd root, okay, or an nth root, and your n is odd, whatever sign you have right here, if it's positive, then your root is going to be positive. If it's negative, then your root is going to be negative. Okay? It is what it is. It will match whatever you have. Whereas if you have an even root here, you're either going to have one of 3 things. Either no roots, 1 root, or 2 roots. So in this case, I need to know what are my perfect 4th powers. What number times itself? What is 1 times itself 4 times? 1. What's 2 times itself 4 times? 16. What is 3 times itself 4 times? 81. 4 times itself 4 times, or really all you have to do is basically take your numbers over here. What's 64 times 4? Okay, to find your next number. Anybody want to take a stab at it? $56. There we go. And then 625. And those numbers are going to go really high really fast. Okay? What's another easy one? Like, if I don't go with the 6 or the 7 or the 8 or the 9, what's the next one for the 10? The 10 is going to be an easy one, right? What do we have to do? Just add another 0, right? So like if we have a perfect 4th, like 10,000 is an easy one. Okay. So with what we have do I have 81 in my list? So I'm looking for a number, x to the fourth power, that's equal to 81. Is it an even or an odd root? It's even, right? So how many different answers can I have? Is this positive or negative? Positive. So what number times itself 4 times is going to give me 81? 3, right? So my root here is not just positive 3, but it's also negative 3. Now, how this normally will look is like if I would take, or if you would type this in, this is basically so you can do this without a calculator, okay? And using your list of numbers and your perfect cubes or your perfect fourths or your perfect fifths, things like that. But if I have like the fourth root, it's just going to look the same way, and it's just going to be the fourth root of 81 is going to be plus or minus 3. Okay. If you type this into your calculator, whatever you have, graphing, scientific, whatever, and you type the fourth root of 81, you're going to get just a positive 3. You need to know that because this is even, that it's going to have a plus and a minus. Same way, just like we did with the square root of 81, and we had a plus or a minus 9. It works the same way. Now, whenever we write rational exponents, okay, whenever we have a rational exponent, basically that just means that we can always write any of these as a radical with an exponent. Okay, so we can solve these. We can always do this without a calculator. Okay, that is always an option. And I would tell you sometimes it is probably a little bit easier to do it without a calculator than it is with a calculator, because in some cases you'll still get a fraction or a decimal that you may not know what it is, just because it's just going to keep going on and on. And in this class, do we round anything unless told otherwise? No. Okay, we leave it as a perfect form, so we want to leave it as a fraction. Okay, so whenever we do this, if we have any number taken to an exponent that is not a whole number, that's not squared, that's not to the third, that's not to the fourth, but it's taken to the 2/3 power, or it's taken to the negative 3/5 power, what we can do is we can turn this into a radical, and we can actually go the other way as well. So like if I have the 16 to the 2/3 power, okay, all I'm going to do with my value is, if I have 16 to the 2/3 power, what I'm going to do is take, okay, if you notice here, now I write it a little different. Whatever your denominator is, okay, that is going to be your root of your radical. Okay, I will be the first one to tell you, I skip this step right there, okay, and I just immediately go from one to the other. All right. So knowing that, I don't rewrite it as 1 to the nth power, or 1 over n. I just basically put it as the cube root, okay, as the cube root of 16, and then all to the second power. Now you can do this a couple different ways. Okay, you can put the 2 inside with the 16 if you want. I usually will put it on the outside and then go from there. So whenever I do this, is 16 a perfect cube? Is there a number that I can multiply by itself to give me 16? Remember, of my numbers, I had 1, I had 8, I had 27, 64, 125. I've already passed 16, right? Okay, because 16 fits kind of basically right here. Just like we did with a square root, how can I rewrite the cube root of 16? Is there a number, is there a perfect cube that I can factor out of 16 as I basically move up my list? Can I rewrite 16 another way? Can I write it like this? What's the cube root of, what's 16, or what's 8 times 2? 16, right? What is the cube root of 8? 2, right? So what is this going to turn into? 2. So I have 2 times the cube root of 2 squared. Now, from here, okay, the reason why I put the 2 on the outside, from what we did before break, what's 2 squared? What's 2 times 2? Anybody want to take a shot at that one? 4, there we go. Now, I'm going to do the same thing with that 2, but I'm going to put it inside here. What's 2 squared? 4. So I'm going to have then the cube root of 4. That's my final answer. Okay, that 2 goes on the outside with the big 2, and it goes on the inside with the other 2. It'll hit everything except for the root. Is 4 a perfect cube? Is 4 in my list over here? No, so I can't do anything with it. It's the same idea as if I would have had the square root of 32. Okay, it's the same thing, it's just now we're using a different list. Okay, before, whenever we had the square root of 32 and we simplified everything, okay, we simplified everything, but we stuck with one list. Here, it's like you've got another list of numbers with perfect cubes, perfect fourths, things of that nature. So then here I have 32 to the negative 3/5 power. First off, with anything that's negative, what do I need to do with my number? Can I flip it? So if I have 1 over 32 to the 3/5 power. Why am I able to do that? Because of that negative? So then as I go, I'm going to have the 5th root of 32, and then all of it is cubed. Now, we didn't have a list for 5th powers. What you probably want to do, what's 1 to the 5th power? What's 2 to the 5th power? Huh? 32. So I could stop there, right? I would probably go to like whatever 3 to the 5th is, 4 to the 5th, 5 to the 5th, and know those first 5, especially to the perfect 5th powers, because then it's probably not going to really get past that because you're going to get some really big numbers really fast. So what is the 5th root of, what is this part right here going to turn into? What is the 5th root of 32? 2. So I have 2 to the 3rd. What's 2 to the 3rd? 8. There's my answer. I wouldn't be afraid of making yourself like a small little table, okay, so you can start to kind of learn to go in and out and figure out which lists you will use and where you'll have it, like as far as what your perfect values are. I would at least go to like 10, like, 1 to the 2nd, 2 to the 2nd, 3 to the 2nd, so on and so forth. Okay, and at least go about, and then as you get to like perfect 4th powers, perfect 5th powers, you probably only need to go about 5. Okay, so then you can kind of see where those numbers are, so then you can kind of go from there. Now, again, the second page where it says to evaluate each expression using a calculator, round your answer to 2 decimal places, then you'll actually round. Okay, and you'll actually use a calculator. Okay, with these though, make sure, like if you do 9 to the 5th power, you can do it one of 2 ways as far as your calculator is concerned. You can either go 9 and then hit the little caret button, and I would put a parenthesis around 1/5. Okay, if you're going to do it that way. Or if you want to turn this into a radical, then depending on what kind of calculator you have, okay, if you have a scientific or even if you have a graphing calculator like a TI-84, what you're going to have to do for one like this, so this is the 5th root of 9, right? Because it's all to the 1st power. Then whenever you type a number like this in, you're going to have to go 5, and then if you have a scientific calculator, you're going to have to hit the math button. Alright, so if you have 9 to the 1/5 power, one thing I would tell you not to do is don't hit 9 and then the caret and then go 1/5. Well, if you have this one, if you have an old 83, if you have a newer one, it'll put it up there for you, and then you kind of go from there. Okay? If you have an older, like an 83, you're going to have to go 9, and then you're going to have to put the parenthesis around it. For a newer one where it puts it up in the exponent position, you're okay. Now, if you have an 83, you're going to have to put a parenthesis around it, because if you don't, and like what it'll look like, it would be like 9 to the 1st power, and then the way that it's going to read it is going to be dividing by 5. Okay, that's different than 9 to the 1/5 power. Okay, so if you have a TI-83 or a scientific calculator, you're going to need to make sure you put a parenthesis around your value, around your exponent. If you want to turn this into a radical, so if you want to turn this into the 5th root of 9, what you're going to do is you're going to go 5, and then you're going to hit the math button. And right here where it says, it has a little bitty x, okay? And then, so your 5 is now your x, so you're just going to hit 5, and then you're going to put 9 underneath. Okay? You'll hit enter. Since it's to the 1st power, you don't have to do anything. If it was like 2/5, then you would need to square that value. Okay? So it just kind of gives you another option as far as what you can do as far as how you type it in.